And today we'll be looking at traces of planes. Last series we looked at traces of the line, um, the horizontal plane, and traces of a line in the vertical plane. Now we're going to look at traces of a plane. Alright, so for recap, a plane is a two-dimensional surface made up of points that extends infinitely in all directions. Alright, and we should remember that there exists only one plane through any three non-collinear points. Alright, let's look at all of this now. So, the plane is a two-dimensional shape made up of points, right? So we would have a point here, a point here, alright? A point here, a point here, alright? And so if you look at this, so a point here, a point here, a point here, a point here, and this would make up a plane, right? So all of this would make up a plane. And it's infinite because this could have been extended further or further up. So this plane here is infinite, right? So when we have it like this, it's just a representation, kind of like your AutoCAD screen, where you have to set your drawing limits because the AutoCAD environment is like infinite. So you have to set up your parameters for your drawing space. All right, so this here would be a plane. All right, and that would be our vertical plane, and it's two-dimensional because it has length and width. All right, so here we're going to have our xy, and of course we will represent our horizontal plane, right? So this here would be our horizontal plane. Again, points, and it's infinite. All right, but this line here just brings it to a point where we can work within that infinite space. It's like our boundary. So right, this would be like our boundary for the HP and our boundary for the VP. All right. Now here we will have another plane because remember, we're looking at traces of planes. All right. So here we have a triangular lamina, and a lamina is really a thin sheet of material. Good. Now picture this as your set square. Let's say this is your set square. All right, and it's triangular in shape. And let's say this now was a sheet of cartridge paper, and we fold the cartridge paper in the middle. So the top side of the cartridge paper would be our vertical plane, and the bottom side of the cartridge paper would be our horizontal plane. Now the set square is suspended in space, right? It is suspended in space between the vertical plane and the horizontal plane. Now, should this side of the set square touch touch or penetrate the vertical plane, and should this side of the set square touch or penetrate the horizontal plane, then it would be considered our traces. All right, so this would be your vertical trace, this would be your horizontal trace. What would we call this? If this is your vertical plane and this is your horizontal plane, this is your triangular lamina, which is a plane, right? But the fact that this is at an incline, right, it's at an angle, then we'll refer to it as an oblique plane. We refer to this as a oblique plane. All right, so to follow up, this point here would be the vertical trace, right, where it penetrates or touches the VP, and this point here would be our horizontal trace, where it touches or penetrates the horizontal plane. So let's look over here. So we have H for the horizontal plane trace, V for the vertical trace, and T where the 2 points would meet on the XY. All right. Now again, just for another visual, right? This here would be our oblique plane. So this plane would be said to be at an incline. All right, and then we'd have a triangular lamina ABC, right, which intersects this oblique plane. So here would be a trace. All right, here would be a trace. Now, visually again, if BA is the intersection of the oblique plane, then BA would be your trace. Likewise, if AC is the line of penetration or touching or intersecting, then CA would be your trace. All right. Now, let us look at this example. This is of planes. All right. Here we have an apparatus. Here we have a setup. Right. We have our XY axis, and we have A prime, B prime, C prime. Right. Which would be, let's say it's a set square. And we're looking at the front of the set square, and A, B, C will be the set square that we're looking down on the set square. So this would be the plan of the set square. This would be the front of the set square. Now, the set square is a triangular plane, and we want to find the trace of the triangular plane, right? So we want to find the vertical trace, and we want to find the horizontal trace. Now, the key thing about this is that it's systematic in your approach. Now, when you look, you will see that A prime, B prime has a line, and we could extend this line here until it touches the XY. Or B prime, C prime line, we could extend it and let it touch here. All right. Also, A prime, C prime we could, but if we do that, it will be extended and would have to extend XY, right? So it's just a matter of you choosing which one of the sides you want to extend. The key here is extend the one that is most convenient, all right? So therefore, AC would not be convenient because it would require you to extend your XY, all right? So the most convenient one would be A prime, B prime. All right, so let's go. All right, so here we have a triangular lamina for our plane. So step one, we extend A prime, B prime. Now, once we extend A prime, B prime, we're going to get D prime. Where D prime touches the XY axis, we're going to extend a perpendicular line down. So this perpendicular line down, now, which line did we extend up here? A prime, B prime. So we need to do the same for here. So if we use A prime, B prime, we're going to use A, B. All right, so we're going to extend AB. So once we extend AB, we have now located a point. And this is a point that will be used for plotting our trace. All right, so we have D at that point there. All right, now B prime, C prime, we extend on this one. All right, I want to extend it here. We're gonna get a line coming down. All right, so once we have this line coming down, all right, we could call this E, but it doesn't really matter what you want to call this point. So we extend this line down. Now remember, it was B prime, C prime that we extended, so we have to look for BC. So here's BC, and we're going to extend BC to cut this perpendicular line. So now that we have the BC extended and cut this perpendicular line, we now have 2 points. 1 point here, 1 point there. 2 points. So these 2 points are what we're going to use now to plot the trace, sorry. So we're going to connect there through the points, and this now would be our horizontal trace. So this would be the horizontal trace. All right, now for us to get the vertical trace, again we would similar to what we did up here, we want to extend a side. So therefore we could use AB. We could extend AB, look, see that we could extend AB. But is that the convenient one? Not necessarily. We could also extend BC. But would that be convenient? Um, Up to you, right? I think AC is more convenient right here, right? So with AC extended, here we're gonna bring this line up, and remember, it was AC that we extended, so we're looking for AC, which is A prime, C prime. So we're gonna extend that. So once we extend that, we now have this point. Good? We have this point. So we are going to now connect from here through this point. And this would give us our vertical trace. Now, what if we had extended BC? If we had extended BC all the way up here, so BC would be extended up here, and then would have to extend BC to meet it. Now, anywhere it meets here, right, you just extend it to, you just extend it to here, right? That is why I said that AC for this scenario would be most convenient. AC would be most convenient so for us to get this point. So this is how we get our horizontal trace and our vertical trace. All right. So H, V, and we're going to have T there. All right. So we have our HT and our VT. All right. That is it.